All right, section 9.3, hyperbolas. This is our last section for the course, so I hope you've enjoyed this. All right, so here's a hyperbola. This looks like a big mess. I understand that. So if you want a better picture, look in your book because your book has awesome pictures of these things. But basically what it is, you can see the curve here and there's a lot of other stuff going on. What a hyperbola is you can kind of think of it as an ellipse that's been flipped inside out. And so the foci, instead of being inside like they were with an ellipse, are on the outside of the graph. We still have the center. I've drawn this one at the origin, but all of our formulas are just going to be randomly on the graph. The vertices are these 2 points here where the graph gets closest to the center. The horizontal axis for this one is called the transverse axis because it passes through all the foci and vertices. We will see them turned vertically also, and then the transverse axis would be the vertical one. The other axis is called the conjugate axis. And then we have these asymptotes that the graph follows on its way out. Importantly, so our foci, our vertices will be at A. And then if we have these B values, which we're going to see over there in the equation here in just a second, the vertices, if you made a box out of the A's and B's, the asymptotes would go right through the corners of that box, but my board was already a mess. So take a look in your book, see the really nice pictures that they have going on there. But here's the formula for when the transverse axis, this guy that goes through the vertices and focus, is parallel to the x-axis. We have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. The center is still at h and k. The vertices are h plus a comma k and h minus a comma k. This should look really familiar. That's almost identical to what we have for ellipses. However, this time we have no stipulation that a has to be the bigger value. Okay, and so actually the way we're going to tell the difference between the two directions, sideways facing or up and down facing, the positive one will always be the direction it's facing. So since x is the positive fraction here, this would be facing out to the sides. This time for the foci, c squared is a squared plus b squared. If you remember with the ellipses, it was a squared minus b squared. So that's a little bit different. Try not to get them mixed up. That'd be bad. But then the foci work the same way. H plus c comma k, h minus c comma k. Because again, everything's going sideways here. So we add and subtract from the x coordinate for the center. The asymptotes are a little bit weird looking. But basically what we have is the h and k here, they act just like the shifts that we've had for all of these graphs. You'll notice it's really easy to see here with the x minus h. It's in parentheses. You're like, hey, that looks just like the x minus h that was up at the top. The y minus k, I don't have it in parentheses because there's nothing else on that side, but it also looks the same. And so what we're doing is we're actually doing a shift on our lines. Isn't that kind of fun? We take our lines that might have gone through the origin like I had them drawn here, and we shift the lines along with the rest of the graph. The slope, b minus a, comes out of the fact that we're making that box I talked about here. And so since slope is rise over run, the rise is b, the run is a, and there's your slope. And oh, look, b and a. So when we find these slopes, it's just going to be, now you're going to need the b, not the b squared, but it'll be this value over that value. And we have plus or minus because there are two of them going, one positive and one negative. Very fun, very exciting. Let's get the other formula up and then we'll do some examples. Okay, so all I've changed here is I just changed it. So, oops, I didn't write it down. We're parallel now to the y-axis. I didn't write that down here. I should have. Here's our formula. Notice that now the y piece is in front. It's the positive value. It has a underneath it, and that's just traditionally how we write that. But again, there's no guarantee that a is bigger than b. And we don't have that guarantee like we did for ellipses. So the center out is hk still. The vertices, now we're adding and subtracting a from that k value of the center because we know that this thing is opening up. Look at the book. It's opening up and down. C squared is still a squared plus b squared. We add and subtract c to the k value to get the foci. And then the asymptotes, the only thing that you'll notice that's changed here is that the a and b have switched places in that slope, right? It was b over a, now it's a over b. That's just reflecting the fact that it's always rise over run, and so here a is the rise value because it's under the y, and b is the run value. All right, let's look at some examples. All right, we're going to continue on. I did just remember we need a homework note here. You're going to stop at number 57 on this section. So there's your homework note for this section. All right, we want to find the center of vertices, foci, and asymptotes. Just a few things. For x squared over 16 minus y squared over 25 is equal to 1. So I notice that a is 4 and b is 5, and I also note that this is going to be going sideways. Okay, it may or may not be at the origin, but I know it's sideways because the x fraction is the positive 1 and the y fraction is the negative fraction. All right, so a is 4, b is 5. So if I come over here, I know that my center is at 0, 0 because remember, center is x minus, we're using h and k, but there aren't any h or k's because they're 0. So we have a center at 0, 0. We're going to use a to find the vertices. So since we know we're going sideways, we add and subtract 4 to the x coordinate, which is 0. So we get 4, 0, and negative 4, 0. To do the foci, we need to find c. For hyperbolas, c squared is 16 plus, a squared plus b squared. So in this case, 16 plus 25. This is 41. C is the square root of 41. Again, I add and subtract that square root of 41, but since it's just 0, we get positive square root of 41, 0, and negative square root of 41, 0. The only thing left then are the asymptotes. Since our center is at the origin, you'll notice I don't have y minus anything here or x minus anything. I just have y is equal to plus or minus, and then here's my slope, the rise over run. And again, we're making this out of that box that we had with a and b. And so since b is with y, we know it's rise over run. We get a slope of 5/4 rise over run. Plus or minus 5/4 x. Nice straightforward example. Nothing like the one that's coming next. So it'll be fun. All right, here we go. Last example for hyperbolas. We want center, vertices, foci, and asymptotes again, but this time you'll notice we have a complete and utter disaster. We're going to complete the square 2 more times. I know you're all very excited. But so here we go. So I started by rearranging this so my x's were next to each other and my y's were next to each other. Be careful with your signs. Make sure they stay the way they're supposed to be. And I also moved that positive 79 over to the other side to make negative 79. Since I know I need to complete the square, I can't do it with the 16 out front of the x squared or the negative 9 in front of the y squared. So I factored those out. Factor out 16, which gives me x squared minus 2x, and then I left a space, which you can see I've already filled in with a 1, but that's okay, we'll get to that in just a second. Same thing here. I factor out that negative 9, gives me y squared plus 6y, and again I had a space, and then I added 2 spaces to the other side so that I would be able to fill in those numbers on both sides. All right, so for x, we take that b, that middle term, that negative 2. When you cut it in half, you get negative 1. Square that, you get 1. That's where this 1 comes from. For the y's, we take the 6, cut it in half, which gives us 3. Square it, you get 9. There's the 9. But remember, when we add it to the other side, we're not really adding 1. We're adding 16 times 1, or 16. We're not really adding 9. We're adding negative 9 times 9, or negative 81. So when we clean all that up, again, ignore that division down here for just a second, we get x minus 1, because remember, we're using the number that we get when we cut it in half. So x minus 1 squared minus 9 times, and then the y plus 3 squared is equal to negative 144. That almost gets us to standard form. Okay, but we do still have this negative 144 here. We have to get rid of that. We need a 1 basically, so I just divide it by itself. But if I'm dividing here, I have to also divide both of those. But that's okay, because it's going to leave us with exactly what we want. Now, importantly, notice that we'll have a positive 16 divided by a negative, and then a negative 9 divided by a negative. So the order here is going to switch, because the y's are now going to be the fraction that has the positive value, and the x's will be the negative. So that's why I switched these over here. So when you do that division, 9 over 144 reduces to 1 over 16. 16 over 144 reduces to 1 over 9, and now the minus sign is on the x's. So from that, I can see that a is 4 and b is 3. we know that since y is leading the way here, it's the positive value that this thing will open up and down. So my center, remember, it's what makes 0, 1 and -3. For the vertices, now we're going to add and subtract 4, but we add it to our y coordinates because, again, everything's going up and down here. So I add 4 to the -3 and we get 1, 1. I subtract 4 from -3 and we get 1, -7. To find the foci, I need c. C squared is a squared plus b squared. 16 and 9 makes 25. This one actually works out nicely. You get c is 5. And so again, adding and subtracting 5 to the y coordinates because everything is up and down. We get 1, 2, and 1, -8. Finally, we have the asymptotes. Remember I said that what we're basically doing here is we're shifting lines off of the origin. It's just a real slick, easy, nice way to do that. So I use the same x and y bits that I had up top. I had a y plus 3. I'm going to use y plus 3 here. I had x minus 1. I'm going to use x minus 1 there. The only thing I still need is that slope for my line. But remember, it's always rise over run, and we're building it off of the a and the b. So in this case, a is the rise and b is the run, since we're going vertically. So I just put a plus or minus because there are two of them, one positive, one negative, with the rise over the run. And there you go. That is hyperbolas.